So the first advanced topic we're going to talk about with inheritance is the topic of abstract classes. An abstract class is essentially a placeholder that you can put into your class hierarchy that represents a general concept. So abstract classes represent objects that have common characteristics of all the child classes that are below them in the hierarchy, but they're too general or too generic to actually be able to create objects of that type. Okay, so if you have an abstract class, you are not allowed to instantiate it. So you can't create an object whose actual type is the abstract class. But perhaps you have a lot of common functionality and features that describe a whole bunch of child classes. Well, you don't want to write them in every single class. Remember, we always want to avoid repeating code. So what we can do is we can take all those common features, those common elements, and we can push them into a single class higher in the hierarchy. And that class would be our parent class. But if that class, again, is kind of too general to be able to instantiate, then we'd make it an abstract class. So a good example of this is going to be our employee classes. So we had our specific kinds of employees that are paid by the hour, employees that are paid via salary, and our unpaid intern employees. So these are all our specific kind of employees. And then we had our parent class employee. Well, in a real life situation, are we ever going to have an employee who is just a general employee, who isn't a more specific kind? Probably not, right? Everyone that works for our company is either going to be paid by hourly, paid by salary, or not paid at all. Or maybe there's going to be some other type of payment like, commission or something like that. But there always going to be some more specific kind of employee. We're never just going to have a general, generic employee who isn't a more specific kind. So employee is a good example of what should be an abstract class, because it's just too general to be able to instantiate. We don't want to actually create an general employee object. We only ever want to create the more specific kinds of employees specified by the child class. But at the same time, even though we don't want to create an employee object, we do want to have all of these common features described in one place. And so it makes sense to put those in a parent class. We just don't want someone actually creating objects of type employee, actual type employee. And that's going to be similar to our audio item. So if we were running a real store, people are never going to download something that's just a generic audio item, right? It's either always going to be a song, or it's going to be a book, or maybe it's going to be, I don't know, an audio game or something like that, a game with an audio component, something like that. It's going to be something more specific. It's never just going to be a generic audio item. So again, this would be a good candidate for an abstract class, because we don't want to actually create objects that are instantiated as this type, but we do want to use this class to group together all of this common information that describes all of the child classes. So that is what an abstract class is. It's a class that you put higher up on your hierarchy, so it's a parent level class, and it contains common information that is shared across all the child classes, but it's too general or too generic to ever actually want to create objects of that type. So if we make a class abstract, then we are allowed to put abstract methods inside that class. So an abstract method is a method that is not implemented. So it's basically just the method header without the implementation. It just specifies the header, right? The return type, the name, the parameter list, but it doesn't have any code inside of it. It just, after that parameter list, just ends with a semicolon. Now, abstract classes are allowed to, and often do, have abstract methods, but note they're not required to have abstract methods. So you don't have to put an abstract method in there, but you have that option. To make a method abstract, you just put abstract in the method header, and then you don't implement it. And the purpose of an abstract method is to say, I want to force all the child classes that inherit from this abstract class to write a version of this method. I want all my child classes to have this functionality that's specified by this method. But I can't implement it in the parent class because all the child classes are going to do it differently. Right? So if that describes some sort of functionality that you want to force to make sure that all the child classes have, but they're all going to do it differently, then you can put an abstract method in your abstract class, and that essentially guarantees that all child classes have to implement that method, but they can each do so in a different way. So if you're a child class and you extend a parent class, you must override any abstract methods. If you don't, then you too, as the child class, will be considered abstract. Okay, so that's how we force the child classes to implement that method. We basically say, hey, if you want to actually create objects of your child class type, then you have to implement this abstract method. Otherwise, you've got to be abstract too. So again, it's a way to force child classes to have a particular functionality, but allow each child class to specify the actual implementation individually. So in addition to our abstract methods, abstract classes can also have implemented methods. So an abstract class often will have methods that are just like normal methods that have full implementation. Okay? Again, they don't have to, so you could have an abstract class that just had all abstract methods, but it's typical to see your abstract classes have a mix of both abstract and implemented methods. If an abstract class has an implemented method, that method is inherited by the child classes, so they do inherit that functionality just like they would from any other parent class, and then they do have the option of overriding it if they want to. So you would put an implemented method in an abstract parent class if all of the child classes were going to have that same behavior. So that's the distinction of whether you implement it in the parent class or whether you leave it abstract in the parent class. If all the child classes have the same functionality and the same implementation of that functionality, then you implement the method in one place in the parent class. But if all the child classes, you want them to have a certain behavior, but they're all going to implement it a little bit differently, then you make it abstract in the parent class and you force the child classes to implement it. Abstract classes are allowed to have constructors. So sometimes this can seem a little confusing because we've already said we can't instantiate an object of an abstract type, so why are we allowed to have a constructor? Well, although you cannot directly create an object of an abstract class type, you can invoke the constructor from the child classes. I would say you can and should invoke this constructor explicitly from the child classes. So just like you would with any other parent-child relationship, the child class should rely on the parent class to instantiate its part of the item, and that holds true even if the parent class is abstract. So again, even though you can't directly create objects of an abstract class type, you can still put constructors in those classes. An abstract class can be used as the declared type of a variable. So this is good to know, right? Because what we wanted to do originally was we wanted to create a whole array of employee objects and then fill it with some hourly employees, some salaried employees. We want to have all our employees kept in one place. And now we know that even if we change employee to be abstract, we can still do that. So you are allowed to have an abstract class be that declared type. And that's sort of, that fact right there kind of brings us all in together. It's what makes abstract classes and polymorphism so powerful, is that we can have this array that holds all these declared objects that are declared as the abstract class, but then instantiate them all as their own child class, whatever makes sense for that object. So here's sort of the bottom line about when you should use an abstract class. If it does not make sense to instantiate objects of that type, but you do want that class to describe common functionality, then you'd make it abstract. Okay, so in general, a parent class, that's what it does, right? It describes common functionality that's shared across all the child classes. But the question is, should it be abstract or not? Well, this is the question you have to answer. Does it make sense to instantiate objects of that type? If it does, if you want to be able to create objects of that parent type, then don't make it abstract. But if that parent type is kind of too general to ever actually instantiate, then you should make it abstract. Once you make it abstract, you have to think about whether the methods should be abstract or should be implemented. And this is the distinction or the question you have to ask yourself. So if all the child classes will use the exact same functionality, then you should implement that method in the parent class. If all the child classes will have the same behavior but have different ways of accomplishing that behavior, then you should make the method abstract and implement it in the child class.